What's up, y'all? Today we're going to be using the shortcut method for long division of polynomials, which is called synthetic division. So you can only use this shortcut when you're dividing by a linear factor, just like this x minus 1 here. Remember that linear factor means that you have a term with an exponent of 1 as the highest exponent, or a factor that is degree 1. So we're going to first look at long division so we can compare the process for long division to the process in synthetic division. So I'm putting my divisor on the left side of my division symbol, and then I'm going to put my dividend, that x squared plus 5x plus 6, inside of my division symbol. I'm going to ask myself the question, what can I multiply by x to get x squared, which is just x. I'll multiply that, so I end up getting x squared minus 1x. I'm going to subtract the entire expression. So this is where I use that different color so that I can see my sign change. 5x plus 1x is going to give me 6x, and then I can bring down that constant at the end. I then want to ask myself that question again, what can I multiply by x to get 6x, which is just 6. And then 6 times x is 6x, and 6 times negative 1 is negative 6. Then from here, I'm using that other color to subtract the entire expression. So that negative 6 will change to a positive 6, and 6 plus 6 is 12, which means I have this remainder of 12 with x minus 1, the divisor, underneath. So remember, that tells me that x minus 1 is not a factor of this polynomial. So I'm just going to show that exact same division problem, but using synthetic division. So when you use synthetic division, you're using the coefficients instead of the entire expression, the entire polynomial. So when I'm looking at my dividend, I'm only going to use the coefficients that I see. The 1 in front of the x squared, the 5 in front of the x, and the 6, that's the constant at the end. I'm going to put this little box off to the side, and I'm going to use whatever that divisor is after I set it equal to 0. So I'm going to take x minus 1 and set it equal to 0 so that I can figure out what to put in that little box. If I add 1 to both sides, I'm going to get positive 1, and that's what I'm putting in here. So here we go. The very first step that you're going to take is to bring down that first coefficient. This is always what happens. You should always bring down the leading coefficient. From here, I'm going to take that little guy in the box, and I'm going to multiply by whatever I brought down. I'm going to put my answer right underneath my next coefficient. So 1 times 1 is 1. Now we add down. So 5 plus 1 is going to give me 6. Now I start that same process over. 1 times 6 is 6, and I put my answer under the next coefficient, and I'm going to add down. 6 plus 6 is 12. Now, this is how I write my answer. You're going to look at the degree of your original dividend. Your answer will use the coefficients that you found, and it will be 1 degree less than what we started with. So my answer is going to start with x to the first power. The last number is always going to be your remainder. So here I have that same exact answer that I got when I used long division. Let's try it again with a different problem. So again, I'm going to set that x plus 3 equal to 0, and I would end up subtracting 3 from both sides, so I'm using negative 3. I'm then going to use all of the coefficients for each one of those terms, 2, negative 5, negative 1, and 3. You will always bring down that lead coefficient, and then you will start the process. You're going to take whatever's in that little box and multiply by that thing that you brought down. So the first step is to multiply. You put your answer underneath the next coefficient. So negative 3 times 2 is negative 6. That's going to go right underneath that negative 5. We want to add down. So negative 5 plus negative 6 is going to give me negative 11. Then we just follow that same pattern, and we get negative 3 times negative 11 is positive 33. We're going to add down and get positive 32. And then one last time, we'll multiply negative 3 times 32 to get negative 96. And we'll add down one more time to give us negative 93. Again, here we want to write our answer 1 degree less than what we started with. So since we started with an x to the third, we'll start off with 2x squared minus 11x plus 32. And then that last piece right there, remember, is always our remainder. So it's a minus 93 divided by the divisor, which was x plus 3. And that's our answer. And remember, because of that remainder, this is not a factor of that polynomial. For this next example, we have a binomial divided by a binomial of x plus 1. So remember, we would set that equal to 0 and we would get x equals negative 1. So that's what I'm putting in that little box. So because we start with this quartic term, we need to have a cubic term, a quadratic term, and a linear term before that constant. So remember that we have to fill up those dummy terms with 0 coefficients. Because I do that in long division, I can't just skip out on that in synthetic division. Synthetic division is just the shortcut. So I still need to include those dummy terms, those 0 coefficients for when I'm missing some terms. So we start off here by bringing down that first term and we multiply. Negative 1 times 1 is negative 1. Remember, we add down. 0 plus negative 1 is just negative 1. Multiply again and we get a positive 1. Negative 1 times negative 1 is positive 1. Add down and we get 1. Negative 1 times 1 is negative 1. Add down again, you get negative 1. And then finally, negative 1 times negative 1 is positive 1. You add down and you get 2. So if you didn't put in those dummy zeros, you wouldn't get all of these coefficients. All right, so we got to start with one less degree than what we started with. So 1x cubed minus 1x squared plus 1x minus 1. And then at the end, remember, the remainder goes on top of the divisor as a fraction added on to the end of that fake polynomial. So again, we can't forget here that when you're missing terms that you still need to include those zeros for the coefficients. Now that we've seen a few examples, I want you to try this one on your own. Remember that you've got x to the 5th, so you need to include every single term in descending order from x to the 5th to the constant. So you are missing some terms in the middle there. So pause the video here, try it, come back when you're finished. All right, so if you had some trouble setting it up, I've got the setup here. Remember, you always bring down that first term. So if you still needed a little bit of help, here it is. Keep trying. My biggest question I always get is, how do you get the little number in the box? Set the divisor equal to 0. X plus 4 equals 0. You would subtract 4 from both sides. So you're putting a negative 4 in that little box. All right, answer goes in descending order, one less than what we started with. So 8x to the 4th. Notice how we got a bunch of zeros going on. So that 0x cubed is unnecessary. So is the x squared and the x term. So that all we have left is this constant. We know that it's the constant because it's right before the remainder. And since our remainder is 0, we don't have to write a remainder at the end. Remember, this also means that this is the factor you would find after you factor out an x plus 4. All right, I'm going to throw a fraction at you. So notice here we still have a linear factor because we have x to the first power. So we can still use synthetic division here. But to figure out what we're going to put in that little box, we have to set the divisor equal to 0. We've been using a shortcut, thinking like the opposite. When you set this factor equal to 0, well, we don't know if it's a factor yet, but when you set it equal to 0, you end up getting a fraction, negative 3/5. So I'm going to substitute that negative 3/5 into that teeny tiny little box up there. I'm still going to use all of my coefficients. So 25x cubed, 150x squared, 131x, and 30 for the constant. I don't have to put any zeros here because I'm not missing any terms. I can bring down that 25 first. That's the first step. Bring down that first number. I need to multiply negative 3/5 times 25. Do not let these fractions scare you. You are going to battle these fractions and you will come out victorious. Take it off to the side. Negative 3/5 times 25 can be simplified. 25 divided by 5 is 5. So this isn't even scary. It's negative 3 times 5. Put your answer underneath the next coefficient and we add down. So 150 plus negative 15 or 150 minus 15 is going to give us 135. Let's do that all over again. Negative 3/5 times 135. Bring it off to the side. You don't have to do all this in your head. Negative 3/5 times 135. You can simplify that 135 over 5 because 135 divided by 5 is 27. So we're actually just multiplying negative 3 times 27, which is going to give you negative 81. Now we add down and we get 131 plus negative 81, or 131 minus 81 is 50. We shall battle this fraction one more time. Bring it off to the side. Negative 3/5 times 50. You can simplify that 50 over 5 and change that to a 10. So this is just negative 30. And look at that. 30 minus 30 is 0. We conquered the fractions. We battled them and we were victorious in our battle. Remember, you start with the degree less than what you started with. So this is a nice, pretty 25x squared plus 135x plus 50. All right, I'm going to let you try your own battle against the fractions. Set that divisor equal to 0. Don't forget to include every single term in descending order from degree 3 all the way down to degree 0. And I'll see you when you come back. You should have a negative 1/2 in that little box over there. And remember to bring down that 6. Don't forget to include that 0 coefficient for your linear term. Here are the coefficients that you should have in that final answer. Remember, we start with 1 less than what we started with. So 6x squared plus 4x minus 2. We have a remainder of 0, which is a wonderful thing. Remember that if you find 0 for a remainder, that means that you found a factor. It means that whatever you divided by is a factor of that original polynomial. And this is helping us factor. That is the goal of synthetic division. So thank you for coming. We will see you next time. Adios.